is lectures of basic electronics. Today we are going to discuss about common base configuration. So it is one of the configuration as we discussed in our next lecture, common collector and common emitter configuration. So let us discuss about first what is common configuration. Common configuration, that means if you take common one terminal, that becomes common configuration. As we know, there are three different types of terminal in transistor: emitter, base and collector. We are going to common that particular terminal which is known as common configuration. So in today's lecture we are going to do common base configuration, that means base terminal is going to be grounded, or we can say common. So let us discuss about its basic first. So biasing NPN transistor. Biasing are possible like this. Here we can see cutoff region, forward active region, saturation region and reverse active region, which is going to be used in digital application. So in this chapter we are going to discuss about only three regions: cutoff, active and saturation region. So in order to use transistor as an amplifier, it should be operated in active region. So in this particular topic we are going to discuss about only one operation of region, which is forward active region, or we can say active region, in which base emitter junction should be in forward bias, collector base junction should be in reverse bias. That means its application is as an amplifier. So let us discuss about its circuit diagram. So here we can see common base configuration, or it is also known as transistor configuration. So here it is the circuit diagram of CB configuration. So as per its name, CB configuration, that means common base configuration, we have to grounded or common base terminal in this circuit diagram. So when we common base terminal, at this time emitter and collector are free for input or output terminal. So in this circuit diagram we can see emitter terminal is used for input side and collector terminal is used as an output device. So in this circuit diagram we can see base terminal is common, emitter terminal is connected to the input and collector terminal is connected with the output. So here, as we discussed earlier, that BBE, that means base emitter junction should be in forward bias. Now here there are two different types of battery is connected in this circuit diagram, which is VEE or PCB. VEE we can say BBE. This is the potential difference between base terminal and emitter terminal. So it becomes VBE. So we can say VBE or VEE. So here VBE should be in forward bias. As we discussed in that table, for active region, PE junction should be in forward bias. So how it becomes forward bias here? Here we can see the battery's positive terminal is directly connected with the base terminal. Now base is the terminal which is connected with the P-type region. Here we can see this symbol is NPN transistor. Now NPN is at the base terminal, that means base is connected with the P and battery's positive terminal, that means similar. So it is in forward bias. So we can say this is connected in forward bias. Now VCB. VCB is in reverse bias. How we can connect it in reverse bias? So here we can see VCB's positive terminal is directly connected with the collectors and region. Now VCB positive terminal, that means we can elaborate it in P, and NPN's N is at the collector side. So N and here P both are dissimilar, that means it is in reverse bias. So like this, we can connect forward bias and reverse bias. Now we should identify which are the voltages or be specific input voltages and output voltages. Similarly, input current and output current, because we are going to discuss about input characteristics and output characteristics as well. So we have to identify input voltage. So here it is clearly visible that VBE is your input voltage, so that your current is flowing IE, which is your input current. So input current is IE and input voltage is VBE. Now here we can see output voltage is clearly visible. VCB is your output voltage, and because of VCB the current is flowing IC, that is your output current. That means your output voltage is VCB and your output current is IC. So now let us discuss about input characteristics. Here we can see input characteristics of CV configuration. It is similar to the VI characteristics as we discussed in our chapter number 1, VI characteristics of PN junction diode. So here on x-axis we have to plot different voltage value, and at y-axis we have to plot different currents value. So it becomes VI characteristics. But here remember this is the input characteristics. So we have to take input voltages and input currents. So here on the x-axis we can see VEB, or it is in voltage. So different values of VEB, 0.3, 0.4, 0.5, 0.6, 0.7 and 0.8. This is on x-axis. And at y-axis we can see input current, which is IE, and it is denoted in milliamps or milliampere, 2, 4 and so on. So here this is the VI characteristics of CV configuration, or we can say input characteristics of CV configuration. Now let us discuss about how it will be drawn. Here this is the input characteristics of CV configuration. So as we discussed in our chapter number 1 that forward characteristics of PN junction diode is similar like here CV configuration, because at that time your diode is in forward bias. Here it is also in forward bias. So there is no difference between input characteristics of CV configuration and forward characteristics of VI, or we can say PN junction diode. So here we can draw like this. But one thing is need to remember that VCB is equal to 20 volt, because here your output is also connected to the circuit diagram. So VCB is equal to 20 volt. At this time we will get like this graph. If V changes VCB, then it will become like this. VCB is equal to 10 volt, so we can get like this graph. If we change VCB is equal to 1 volt, at this time we will get like this graph. Now what indicates this? Here we can see this is the RI, which is indicated as input resistance, is equal to delta VBE upon delta IE at constant VCB. Here we can see R, that means it is basically resistance. Resistance is equal to, it is the ratio of voltages to the current. So here delta VBE upon delta IE, from this values we will get input resistance of this characteristics. Now here we can see at fixed value of VEB, your graph is like this. First VCB is equal to 20 volt, and this time your IE is maximum. Here you can see it is around 7 milliampere. Then at fixed value of VEB, your graph is like this. That means if you decrease your VCB value at this time, here we can see in this graph, it is the different value of delta IE. That means your IE is slightly changes to decrease the value of VCB. Here we can see VCB is equal to 20 volt, then after your VCB is equal to 10 volt, at this time your IE, which is your input current, is going to be decreased. So this effect is known as early effect. Because of your output voltage, you will get variation in your input current. Now let us discuss about output characteristics. Now here this is also a VI characteristics of CD configuration, but output characteristics, that means you should take output voltage and output current. Output voltage should be at the x-axis and your output current should be at your y-axis. So here we can see at x-axis there is VCB. So these are the voltages in volts, and at y-axis we can see IC in milliampere, 1, 2 and so on. These are your output current. Now output characteristics is divided into different parts because this is your output characteristics, so it behaves like as a switch and as an amplifier. So there are three different types of regions. First, cutoff region, then active region, and third one is saturation region. So in this diagram we will discuss about these three different types of regions. So let us discuss first cutoff region. Here we can see if your IE is equal to 0, IE is your input current. If your input current is equal to 0, that means your output current is equal to 0. That means your IC, which is also known as collector current, is equal to ICEO. That means it is reverse saturation current. So at this time, no current will flow from transistor. So this is also known as cutoff region. So this area which is highlighted, we can see, is known as cutoff region. Now if we increase the value of IE, that means input current's value is going to be increased. At this time you will get your output current. Here we can see if you will take IE is equal to 1 milliampere, at this time IC becomes 1 or approximately 1, we can say, in milliampere. Then if this IE is equal to 2 milliampere, your IC becomes like this. IE is equal to 3 milliampere. At this time your IC is also different. IE is equal to 4 milliampere and like IE is equal to 5 milliampere, and you will get different in value of IC. Now this region is known as active region. Before that we have to calculate about saturation region. So here saturation region is started from minus side. So why it is so? Because here we can see this is the saturation region. That means your VCB should be in forward bias. So due to this we have to apply minus voltages at VCB side. Then it will come in forward bias. Now here you can see this region is known as active region, and this region is known as saturation region. Now similarly we already discussed in input characteristics. Here we are going to discuss about RO, which is known as output resistance, equal to delta VCB upon delta IC at constant IP. So here we can see this is the different region, cutoff region, active region and saturation region of CV configuration. Now CV configuration for PNP transistor. Here we can see this is the circuit diagram of PNP. Slightly changes is there. BEE is inverse compared to the NPN because plus terminal is connected with the PNP's P-type region. Then it becomes forward bias. So here we can see BEE or we can say BEE becomes in forward bias. And here we can see VCB, it should be in reverse bias because P and P. First is P and which is connected to the battery's negative terminal, and it is dissimilar because there is P and here we can see battery's N. So it is in reverse bias. Its application is used as pre-amplifier circuit. Now let us discuss about transistor current gains. So first, what is gain? Gain is the ratio of output upon input is known as gain, and current gain, that means output current upon input current, is known as current gain. Here we can see there are various types of gain. CV current gain is indicated as alpha, CE current gain is indicated as beta, and CC current gain is indicated as gamma. Alpha is equal to IC upon IE, beta is equal to IC upon IB, and gamma is equal to IE upon IB. One more important equation is here, IE is equal to IB plus IC. IB is total currents 2% only, whereas IC is total currents 98% from this characteristic. Here today we discussed about CV current gain, which is here alpha is equal to IC upon IE. So that's all for today's lecture. If you have any queries related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.